Now you'll see this is with fractions, which we learned about getting the square root out of the denominator in day 1. In day 2, we're just doing operations with fractions. Everything you've learned before with fractions is still applying here. It's not any different than what you've learned in 4th grade or even what we did in chapter 11 when they were polynomials. It's all the same idea. So in the first one, in the first box, you're going to see that I just rewrote the fraction because dividing by a fraction is the same as multiplying by the reciprocal, so I flipped it over. And then under these 2 boxes, I have 2 ways to do it. There's even probably more than that. And I want to emphasize to you, what I would like you to do is try these. Try these yourself. Do what you think you're supposed to do. I'm going to reveal the answers. If you get the answer, that's great. If you don't think that your way was wrong, but let me see it. Bring it into me and say, Mrs. Renfrey, can you look at what I did and we can talk about why I didn't get the same answer? A lot of the times it's just you calculated a number wrong. So please don't think it's only one way. For time's sake, I didn't, for every single problem, do all the ways I could see doing it. For this first problem, I wanted to show you 2 ways. So in the first one, what I did is I divided the 24 and the 27 both by 3. That's where the 8 and the 9 came from. I was dividing these by 3. And then I divided these by a common factor of 2. So I divided 8 by 2 and 50 by 2. So here I was just simplifying the numbers underneath. Then what I did is I simplified the square root of 8 to 2 root 2. I said the square root of 25 was 5. The square root of 4 was 2, and the square root of 9 was 3. Then, just like with all fractions, I multiplied across the top and across the bottom. And I checked, can I make this any smaller? Nope. Can I simplify the 4 and 15? Nope. Is there a square root in the denominator? Nope. So I'm okay. That's my final answer. Now this is the same problem, it's just done slightly differently. So what you'll see here is I simplified the square root of 24 to 2 root 6. I simplified square root of 50 to 5 root 2. The square root of 8 to 2 root 2. And the square root of 27 to 3 root 3. So I just chose to do something a little differently first. Well, the root 2's can cancel. The root 3 can cancel with the root 6, leaving me a square root of 2 here. Then again, I can multiply across the top and across the bottom, and I'll get 4 root 2, 15. Honestly, guys, you could have multiplied across the top and across the bottom to start and simplified. There's probably 3 or 4 different ways to get to the answer. So again, what I'd like you to do is push pause and try these. Just try them. Watch what I do when I explain it, but please don't erase the attempt you made. Bring it into class, let me see it, and say, Mrs. Renfrey, can you look at what I did and talk to me about why mine might not work? Honestly, it's probably something very small, and if you'll give me a chance to look at it, I'll probably say your way is fine. We just have to tweak it a little. All right, so push pause and try these. All right, for the next one up top, I didn't do it all the ways. What I did is I simplified the 6 and the 12. That's where I simplified the 6 and the 18. I divided both by 6, so I get the square root of 1 over the square root of 3. Then I multiplied across the top, that's where the square root of 5 came from. I multiplied across the bottom, that's where the square root of 36 came from. And then I said the square root of 36 is 6. So the final answer is root 5 over 6. Many ways to get that. In this one, okay, I chose to simplify the square root of 18 to 3 root 2. I left the square root of 7. I made it the square root of 14 over the square root of 5. The next thing that I did was I simplified here by dividing both by the square root of 7. That got me to here. I multiplied across the top and the bottom. I said, wait a second, the square root of 4, I know what that is. That's 2. So 3 times 2 is 6. And then I said, oh, right, I can't leave it as 6 over root 5. I have a square root in the denominator. So I multiplied top and bottom by the square root of 5, and that's where my final answer came. In the last one, I multiplied by the reciprocal, again, I chose to simplify first. So I divided the 24 and the 3 each by 3. That's where this, by the square root of 3, I should say. That's where these came from. Then I divided the 32 and 22, square root of 32, square root of 22, both by the square root of 2. That's where these came from. Okay. And then I said, oh wait, look, let me look at this again. I could simplify the square root of 16 with the square root of 8 and make that the square root of 2 over the square root of 1. So I simplified here, again, dividing this and this by the square root of 2, this and this by the square root of 3. And then I looked again and said, you know what, I can simplify the square root of 16 and the square root of 8. So I got to here. Again, look at the right fraction. That didn't change. I multiplied across the top and the bottom. I said, wait a second, I can't leave my answer like this. There's a square root in the denominator. So I multiplied top and bottom by the square root of 11, and I got to the square root of 22 over 11. In the next ones, we're adding and subtracting. So remember, you need common denominators. And again, many, many ways to get to the answer. In the first one, once again, I will show you 2 ways, and the other ones I just stuck with 1. So in the first one, what I did is I simplified all the square roots. Square root of 12 is 2 root 3. Square root of 50 is 5 root 2. Square root of 27 is 3 root 3. Square root of 8 is 2 root 2. And then I said, well, I'm adding and subtracting. I need common denominators. I see they both have a root 2, so that's good. But I need the number in front to be the same. So what can 5 and 2 go into? 10. So I multiplied top and bottom here by 2. That's where this fraction came from. And on this side, I multiplied top and bottom by 5. That's where this one came from. Now I have common denominators. So I subtracted the numerators. That's where the negative 11 root 3 came from, and kept the denominator. I got to here and said, wait, I can't leave my answer like this. There's a square root in the denominator. So I multiplied top and bottom by the square root of 2. That's where these came from. The square root of 4 is 2, so 10 times 2 is 20, and that was my final answer. In another way to do it, same problem, just different solution. I simplified all the square roots first. You'll see me do that a lot. I like to have smaller numbers. And then what I did is got the square roots out of the denominator first. I decided that was more important than common denominators. So I multiplied top and bottom here by the square root of 2. Okay, and top and bottom here by the square root of 2. And that made my numbers in the denominator just regular integers. So I said, okay, what's a common number that 10 and 4 can go into? It's 20. So I multiplied top and bottom here by 2, top and bottom here by 5. Again, added the numerators, kept the denominator, same answer. So again, I'd like you to try these 3 on your own, and then come back, check your answer. And again, if you try a way and it doesn't work, it's fine to write my method down, but please come in and show me or talk to somebody about and say, well, why didn't my method work? It's important to know that my way, the way I'm about to show, is not the only way these problems can be done. Okay, so here I simplified all the square roots. I left the root 2, said, okay, they match, but I need a 4 in front of each. That's why I went here. I added the numerators and kept the denominator. Now I got this fraction, I canceled the 4's, that's where this came from, and then I multiplied top and bottom by the square root of 2. Over here, again, I started with simplifying all square roots. In this one, I chose to do it a little differently, using kind of the other method, where I multiplied top and bottom by the square root of 2 in this fraction. Sorry, I know that's kind of messy. And I multiplied top and bottom over here by the square root of 2. Okay. So that's where the 10 and the 6 came from. So now that I have whole numbers, I said, oh, I need a common denominator, so I multiplied this one by 3 over 3, this one by 5 over 5. I added the numerators and kept the denominator. In this one, please remember the square root of 27 is the same as the square root of 27 over 1. I simplified the square root of 27. I decided to get the square root out of the denominator, so I multiplied top and bottom of the right side by the square root of 3 over 3. And by doing that, I got to 6 root 3 over 3. And part of my reasoning on that was I said, you know what, look, if that 3 wasn't under the square root, I could totally cancel that with the 6. So to get it out, that's why I chose to do this first. Again, you don't have to do that. Now that I'm here, I know I can divide the 6 and the 3 and get 2 root 3. 3 root 3 minus 2 root 3 gives me 1 root 3, or root 3, as my final answer. These 3 problems, I'd really like you to push pause, try them on your own. Just try something, because when you try it, at least you're thinking about it and there's thought. Again, come back. You can see what my answer is and hear the way I did it, but talk to me or a friend about why yours didn't work if you don't get the same answer. So push pause now. All right, for these final ones, remember that 22 is 22 over 1. So this should be 22 root 2 over the square root of 11. Not 22 root 2 over 22 root 11. If there was a 22 on the top and the bottom, that's not 22 wholes. So I started by getting the square roots out of the denominator. Again, my choice on that was, hey, if this 11 wasn't under a square root, I could simplify that with the 22. So that's why I chose to do that. I got the square root out of the denominator. I simplified the 11 and the 22, and the 2 and the 22 common, so I added and got to there. In this one, a similar story. Okay, I started by rewriting everything. Again, it's not 8 root 5 over 8 root 2, it's 8 over 1, so the 8 goes on the top, and it's same with the 15 here. I chose to get the square roots out of the denominator first. Again, you don't have to. My reasoning behind that when I did it and looked at it was, hey, if the square root wasn't here, then I could have simplified the 2 and the 8. So I got it out, multiplied top and bottom by root 10. From here to here, it's just me simplifying the square root of 90. And over here, I multiplied top and bottom by root 5. That's where this came from. Then I divided the 8 and the 2. That's my 4 root 10. I brought down my 3 root 10. 15 divided by 5 is 3 root 10. 4 plus 3 is 7. 7 minus 3 is 4 root 10s. And finally on this one, I put everything, separated. I got the square root out of the denominator. I said, okay, now I'll simplify the 15 and the 3. And then I have 6 root 2s, I have 3 root 5s, and I have 5 root 3s. Well, that's the best I can do. So this whole thing right here would be the answer you would put in the blank. All right, that concludes 12-3 day 2. Again, I encourage you to have tried these, and even if you copy my work down, which is great, come talk to me about why your way didn't work. Please don't just erase it, or try and look yourself and see why something didn't work.